Hey everyone, and welcome! Have you ever wondered how a simple magnifying glass can actually start a fire? Or, how our own eyes manage to bring this whole world into sharp focus? Well, it all comes down to a really cool secret about light. So let's dive in and see how the simple act of bending light literally shapes everything we see.
So we're going to kick things off with a classic mystery. I'm sure you've seen this in movies or maybe even tried it. How can a totally normal, clear piece of glass take all the sunlight around it and concentrate it with so much power that it can literally set paper on fire? I mean, it seems like magic, right? But I promise you, by the end of this, you'll see it's just beautiful, beautiful science.
Okay, so the very first clue to solving our little fire-starting puzzle is a surprising fact. See, we all think light travels in a perfectly straight line, and most of the time it does. But under just the right conditions, it can bend. And that bend, well, that's the key to everything.
And that bend has an official name. It's called refraction. Now, this is a super important definition, especially for your Class 10 syllabus, so make a note of it. Refraction is just the scientific term for the bending of light when it goes from one clear material, like air, into another one, like glass or water.
But why? Why does it bend? Well, imagine you're driving a car on a nice, smooth road, and all of a sudden, your right wheels hit a big patch of mud. What happens? That side of the car slows way down, and it makes the whole car turn, right? Light does the exact same thing. It zooms through the air, but the second it hits something like glass, it slows down. And that sudden change in speed is what forces it to bend, changing its path.
So, is this bending just random? Does light just bend however it feels? Of course not. This is physics we're talking about. There are always rules. And the rules that tell us exactly how light is going to bend are actually pretty elegant and totally predictable.
There are two main laws you got to know. The first one's pretty simple. The light ray coming in, the light ray that gets bent, and an imaginary line we draw straight down from the surface, we call that the normal, they all stay on the same flat surface. But the second law, that's the powerful one. It says there's a very specific mathematical link between the angle light comes in at and the angle it bends away at. And for any two materials, that relationship never, ever changes. It's a constant.
This constant relationship is all wrapped up in a famous little formula called Snell's law. This simple equation, this is like the secret code that lets scientists figure out exactly how much a ray of light is going to bend. It's the building block for designing everything from your eyeglasses to the camera on your phone and even those crazy advanced telescopes. Okay, so Snell's law tells us there's a constant. The next obvious question is, what is that constant? What does it actually measure? Let's find out.
That constant is called the refractive index. The easiest way to think about it is like a rating for how much light-bending power a material has. So if something has a high refractive index, it means it slows light down a lot, which means it bends it a whole lot more.
And wow, check out how much this bending power can change. You can see air. It barely bends light at all. Its index is super close to 1. Water has a bit more muscle. But then look at diamond. Whoa! Its refractive index is massive. That incredible power to bend light is exactly what makes the light bounce all around inside a diamond and create that brilliant sparkle we all love.
And this brings us to another key term, optical density. It sounds fancy, but it's simple. A material with a higher refractive index, where light moves slower, is called optically denser, and a material with a lower index is optically rarer. The main thing to remember is this. When light enters the denser material, it slows down and bends towards that imaginary normal line.
Okay, so let's recap. We know light bends in a predictable way, and we can even calculate how much. So what if we got clever? What if we could shape a piece of glass just right to control exactly where all those light rays end up? Well, my friends, that is precisely what a lens does.
Yep, a lens is just a carefully shaped piece of glass or plastic that's designed to control light. And there are two main types you'll see. The first is a convex lens. It's curved outwards, and it makes parallel light rays converge, or come together at a single point. The second is a concave lens. It's curved inwards, and it does the opposite. It makes the light rays diverge, or spread out.
And here's a super simple trick to tell them apart, something you can literally feel. A convex, or converging lens, bulges out. It's fat in the middle. A concave, or diverging lens caves in. It's thicker on the edges. Easy, right?
All right, it's time for the big reveal. We have all the clues, we know light bends, we know we can control that bend with a lens, so let's finally put it all together and see how this solves our fire-starting mystery and creates the images we see everywhere.
And boom, here is our answer. A convex lens takes all those parallel rays of sunlight hitting its entire surface, and because of refraction, it bends every single one of them so they meet at one tiny, super bright spot. All the sun's energy gets focused right there, generating a ton of heat, enough to make paper burst into flames. Mystery solved.
But lenses do so much more than start fires. They form images. Let's stick with our convex lens. When an object is pretty far away from it, the lens creates an image with three key features. It's smaller, it's upside down or inverted, and it's a real image, meaning you could actually project it onto a screen. This is basically how a camera works.
Now, let's start moving that object closer. If you place it at a very specific spot called 2F, something cool happens. The lens still makes a real inverted image, but now it's the exact same size as the original object. This is the principle used in things like photocopiers.
Okay, last one. What happens if you bring the object super close to the lens, even closer than the focal point? Well, everything flips. The image suddenly becomes upright, it gets much bigger, and it's now virtual. You can see it by looking through the lens, but you can't project it. And that, right there, is exactly how a magnifying glass works.
So we've totally solved the mystery of how light bends and how lenses work. But what about the mystery of absolutely acing your Class 10 science exams? Because let's be honest, that can feel just as tricky sometimes, but it really doesn't have to be.
If you've ever looked at your textbooks and just felt totally buried under all the formulas, the definitions, the diagrams, we get it. It can feel overwhelming. But you don't have to worry because at A1 Institute, we are here to be your guide through all of it.
You know how we just broke down this whole topic into simple, easy steps? That's what we do for everything. With our expert teachers guiding you, our crystal clear study notes, and our focus on solving problems step by step, we give you the confidence and the tools you need for guaranteed exam success.
If you found this helpful, if things started to click for you, just imagine having this kind of clarity for your entire syllabus. Do us a huge favor and hit that like button, share this with your friends who might be struggling, and most important of all, subscribe to the A1 Institute YouTube channel for more lessons that make science simple.
So, are you ready to take that next step and really master your studies? For admissions, to get our exclusive notes, and for one-on-one guidance, please get in touch with us today. All of our contact info, including our phone number, is waiting for you right there in the description below. Thanks so much for watching.